This video goes over how to write an equation based on a trigonometric graph. So the first thing I'm going to do is identify the pattern that the graph suits, whether it's sine or cosine. This one looks like a snake, so I'm going to model my function after sine x. So I know that I need to identify my amplitude. I need to figure out my k value from my period. I need to figure out the phase shift, and I need to figure out the equation of the axis. So the equation of the axis is right in the middle here, which is y equals -3. That is the d value of my graph, or the vertical shift, so plus d at the end. I can also find the equation of the axis by doing the maximum plus the minimum, and then dividing by 2. So in our case, our maximum value is -1. I'm going to add -5. I get -6 divided by 2, gets me to that -3 value. From there, I can find my amplitude. So the amplitude is going to be this value that I've done in red here. So I can count on my graph that my A value is going to be equal to 2. I can also find my amplitude by doing the maximum, take away the minimum, and then dividing by 2. So my maximum again is -1. I'm going to take away the minimum, which is taking away -5. So I would get 4 divided by 2 would give me a value of 2 for the amplitude. I know that the A value is going to be positive because it follows the same pattern as regular sine, going up to a maximum first, so there's no reflection. I can see that it doesn't start at the y-axis, so I do have a phase shift. That is how far that the starting point has moved. So I can see that my new starting point for sine is right at -π/2. So that means that my phase shift, which is my starting point, is π/2 to the left. Once I've done those three characteristics, the last thing that I need to do is the period, which is the length of time to complete one cycle. So we'll do it in purple here. So that is the distance between my starting point all the way to the end point. So I can see that I'm starting at -π/2 and that I'm finishing at π/2. So in order to find my period, I'm going to do my finishing point, take away the start point, or graphically I can look at the scale and determine that as well. My finishing point is π/2, and I'm taking away my start point, which is -π/2, which is going to give me a period of pi, which I can also see by using the scale on my graph. If my period is pi, I know that the period and the k value are related using this equation here. So my k value is going to be 2π divided by the period, which is 2π divided by pi, which is going to give me a k value of 2. In order to put all those things together, I'm going to write them all at once. So I've got my amplitude in front, which is 2. Then I have my parent function, so I'm using sine. Now I have my k value. My shift, I'm going to the left, so I'm going to make sure that I've got plus inside my brackets. And then I've shifted down 3, which is -3. So again, the last value is the equation of my axis. The first value is the amplitude. The value being added to the x is the phase shift. And then the last one right here in front is the k value. So let's do one more example. So here I'm going to take a look at using this function right here and going to this function right here. And this scale actually is in terms of pi over 12. I can write them in here just to confirm. So I've got pi over 12, 2 pi over 12. Then I've got 3 pi over 12, which is the same as pi over 4. So those fraction common denominators still apply. This is the shape of the graph that I'm going to be looking at, which matches to a cosine function. So that means that I'm trying to find all the values here. I've got a cos k, x minus c plus d. So the first thing that I'm going to find is my equation of the axes. I can see that my maximum is here and my minimum is here. We are dealing with some fractions. So visually, I can see that the middle point is right through here. So I know that because I've got 3 squares to get down to the minimum and 3 to get up to the maximum. So my equation of the axis is at y equals 1. You can also find it by adding the maximum and the minimum and dividing by 2. Next one that we're going to figure out is the amplitude. The amplitude is 3 squares. In this case, though, each square represents 1/4. So that means that 3 squares is actually 3/4. So that means that my amplitude is 3/4. There is no reflection because of the starting point that I chose. That looks like the cosine function that starts at a maximum. Now I'm going to identify my phase shift. I'm using this green value as my starting point, which looks like it is at, let's see, 3 pi over 12, 4 pi over 12. This would be at 5 pi over 12 to the right of the y-axis. So that means that my phase shift is 5 pi over 12 to the right. And then the last one that I need to find is the k value, or the period. And so now I'm looking for the distance from my starting point to the end point. So my starting point is 5 pi over 12, and my end point is all the way down here. So I'm looking at this one right here. I know that this is 15 pi over 12. And then I've got 16 pi over 12, and then 17 pi over 12. So the neat thing here is that I can see that my period is going to be my end point. Take away the starting point. 17 minus 5 is 12. So I get 12 pi over 12, which is just equal to pi, which is actually the same as the one above. This means that my k value is also the same because the period of sine and cos are the same. And now I can write my equation by putting all those values in. So I have 3 over 4 cosine k x minus 5 pi over 12 because I am moving to the right. And then finally I'm adding 1 to get my equation of the axis. So amplitude is in front, phase shift is inside the brackets, k value is determined by the period, which is the number in front, and then the last one is the vertical shift, which is equal to the equation of the axis.